direction the flow is going. Flow from urine into the blood, or from the blood into the urine. And so I'll use the word nephron, meaning it's going into the urine. So filtration is that first process. Where does that happen, by the way? What structure is going to take care of filtration?
Glomerulus.
Glomerulus and the Bowman's capsule. So the glomerulus is blood, right? So you're going from the blood, and then liquid, including things like water, sodium, chloride, potassium, acid and base, even glucose, even individual amino acids. All of those things are small enough to go out of the blood, pass through tiny filtration slits into the nephron. Okay, so you'll be into the Bowman's capsule. Once you're in the Bowman's capsule, then you're in the process of making urine. They call it filtrate beginning. So the other major point is that, and I'll put that up on the slide as well.
Making urine.
That describes it on the PowerPoint. Proteins are too big to go through the filtration slits. So they do not leave the blood and enter the filtrate. Blood cells, also too big to go through the filtration slits. So you should have no red blood cells or white blood cells or any big cells at all getting into your urine. If you see blood in your urine, you've got a problem. If you see big proteins in your urine, you probably have a problem. So then you want to get that checked out with the doctor. And as I warned before, don't confuse blood from menstruation with blood in the urine. So sometimes people panic and go, oh, that's actually not blood coming from the kidney. They're just menstruating. So the next process is reabsorption. And from reabsorption, what you want to do is recapture useful things. So you don't want to get rid of, for example, glucose, because glucose is an important fuel source, an energy source for you. So you want to capture that. And so I put a star, this is very important. Glucose is 100% reabsorbed, which means it goes from the nephron and is returned back into the blood. So it's usually the peritubular capillaries that recapture that. Also, you're going to recapture your amino acids, because amino acids are an important nutrient. Okay, then thirdly, you've got secretion. Secretion moves things out of the blood back into the nephron. It's like, well, why do you have to do that? We're going back and forth, back and forth. Well, some things you can't filter out enough of, and some things need a little tweaking and readjustment. So, for example, you may all of a sudden be going into acidosis. Maybe you have too much acid in your bloodstream. So then the way you keep your pH balance is you have getting a little too much acid in your bloodstream, you better dump some acid. And it'll actually secrete excess acid back into the nephron, so you'll pee it out. Or if you have excess base, you might need to pee that out. Or excess sodium, or it could be excess fluoride, or anything. So any excess of anything could be additionally secreted. And then usually odd molecules that are relatively large, like penicillin or drugs, things like that, phenobarbital, they could be secreted back into the nephron, so then you're going to get rid of them. Now don't confuse secretion, S-E, with excretion. So excretion is a passive process. When you passive, you don't need ATP to drive these transport processes. And excretion, that's just the finished product. You have urine exiting the nephron. So you go from the nephron out of the body, which means you're going to go into the ureter, to the bladder, out the urethra. And just listing a typical molecule would be urea. So urea is a major component of urine. Not the only thing in urine, of course. I mean, there's still water in urine. But urea is a good molecule to pick because that's nitrogenous waste. You do actually end up keeping a certain amount of urea to use as an osmotic particle to help retain water as well. We'll learn a little bit about that. So filtration, reabsorption, secretion, excretion. Guaranteed to be on the exam. Guaranteed I'll ask you what direction is the flow from blood to nephron or from nephron into blood. And then you need to know several examples of molecules that are